Hey everyone, LeetCode question, battle in a board. Given a 2D array, count how many battleships are in it. The battleships are represented with X's. Empty slots are represented with periods. You may assume the following rules. You may receive a valid board made of only battleships or empty slots. Battleships can be placed horizontally or vertically. In other words, they can be only made of the shape 1 by n, 1 row n columns, or n by 1, n rows, 1 column, where n can be of any size. At least one horizontal or vertical cell separates between two battleships. There are no adjacent battleships. And the last point kind of points to this invalid example. All right, so the obvious solution that many people may think of is related to another LeetCode question, number of islands, where whenever you see an X, you do depth first search and you change all the X's to periods and you increment the counter by 1. And that'll work here, but let's look at the follow-up real quick. Could you do it in one pass, only using O of 1 extra memory and without modifying the value of the board? So we can't actually use depth first search here. So is there a way where we can do this in one pass? There actually is, and it's using the rules of the 1 by n and n by 1. If you see an X, you know that there's a battleship right there. So if you counted this, that'd be 1 ship, that'd be 2 ships, but that'd be 3 ships, and that'd be wrong because there's only 2. Well, what you know is that this can only be of 1 column, and if the current and if there is a possibility that we can check a previous condition, whether we look at the previous column or the previous row, if there's already an X marked, that means that this has already been accounted for. In this scenario, this first X we will count, and then this X we will count as well. But when we hit here, we'll say, hey, there's another X above, and therefore we don't count this. Same with this. So let's see the logic right here. First off, we're going to want to create an integer that represents our count. And now we're going to want to iterate through the board. The first loop is always for the rows, and the second loop is for the columns. And then we're going to have our check right here. Is board at the current position equal to X? Now let's do some logic. If the current row is greater than 0, so we're not at the first row, we're in this maybe another row, and at the previous row in the same position, so just 1 up, if that is already X, then we don't actually want to count this. Same with column. You see the pattern right here? We want to continue because that means we've already counted this somewhere else in our loop earlier on. But if we've both counted these conditions where we check above if possible, we say if greater than 0 so we don't run into the out of bounds condition. If we see that there's already an X above the current position, or if there's an X to the left of the position, we don't actually need to count that. But in the scenario where neither of these trigger, we can increment the count. And this is the solution you want. So let's return count. Awesome. And looks like that's the correct solution. So this is linear time, where n is the length of the board. And in terms of space complexity, it's O of 1 because we're not actually, there's no space that's scaling with the input or the length of the cardboard that we're given. All right, awesome. Liked it, and please share. Thank you.